basically the past couple of days of what do you do when you have a parallelogram? Well, you know certain things occur. Okay? Those parts of parallelograms occur every single time that you have a parallelogram. Now, actually, starting on Monday, we're going to get into the more specific things. Today and tomorrow, we're just going to kind of work through why all of this works. How do you set it up to make sure that it works, and so on. So what we've done in the past is that we've sat there and we've talked about how why four-sided figures are what defines a parallelogram. And when you define that, go away your phone. Take out the math stuff. Put that away. Come on. I know, I'm a jerk. You want it. So if you go back to the idea of what we've done in terms of a parallelogram, we've listed out a bunch of different properties. What was one of them? What's that? That doesn't make it a parallelogram, though. That just makes it a quadrilateral. There you go. So we know this. For it to be a parallelogram, we have to have the following. Opposite sides are parallel. What do you got, Hannah? Opposite angles are congruent. So we have that. So we have opposite sides parallel. Opposite angles. Bless you. Bless you. We have that. What else? Consecutive angles are supplementary. Very good. Consecutive angles are supplementary. All right, that just means they add up to equal how much? 184. Put it away. Come on, put away your other stuff. Come on. I know. Do it another time, man. Thank you. We got more. What else is there? What do you got?
Opposite sides are congruent.
Okay. Opposite sides are congruent.
What do you know about the diagonals?
Sector each other.
They sector each other?
No, it's in my notes, it's just a sector. Bisect,
Oh,
yeah.
there we go.
Yes. Yes. All right. We're making up terms here. Call the geometry division. And like you said, you get bisected parts here. All right. Now, basically what happens then is that in order to show that something is, in fact, a parallelogram, you have to have those things. So what we're going to look at today is you're going to not be told specifically that, hey, bozo, this thing is a parallelogram, but you have to decide if it is not one. That means you have to look at what information is given to you. It's not a proof. Don't worry about that. We're not doing any of those. But this is more of an algebraic idea of how do you show that something's going to work. And you've done this type of stuff before. We've done this type of stuff when we did right angles. Remember when we did right triangles? If the Pythagorean theorem held true, then it was a right triangle. If it was less than or greater than, it was either acute or obtuse, depending upon the values, things like that. So this whole process of showing whether or not something works really isn't anything new to you guys whatsoever at all. It's just in another section. It kind of shows up a lot. Okay? For example, let's really badly drawn. Let me try it. See, this is better. So,
Mr. Murphy,
yeah,
just one question.
what's that?
What is the perpendicular line?
What do you mean? Oh, it just, when I took a picture of it, just snapped in, that's all. Pay no attention to that. What were you gonna say?
Why is there 6 triangles instead of?
Don't worry about it. Again, this is March, and sometimes when you take little snapshot pictures in there, it doesn't get as clean as you'd like it to be, so it happens. So-
Someone's loading a gun with the sounds on.
Remember. So when we go back to this, if you have a parallelogram, you've got your opposite angles congruent, opposite sides congruent, opposite sides parallel, consecutive angles, supplementary, and what was it, diagonals that bisect.
Yeah.
Yeah.
Wait, what is that?
They just sect each other, you know, whatever.
Bisect.
They're just sector each other, you know. Hey, when we get to sectors, you'll be fine.
Okay.
There is a section on sectors in circles. It's the piece of pie. Anyway, so if you're looking at this one here, in order for this to become a parallelogram, which of those 5 things do you think you're going to be working with? I'll give you a hint. It's not the angles. I'm going to guess you're probably right. The reason why I'm going to go with it being the diagonals is because you have one set of said diagonals tick marked saying that they are congruent to each other, which means you have to make sure that the other set are also congruent. So what do?
They are equal to each other.
Yep, set them equal to each other and find the value of x that makes it work. And that's what you're doing.
Or x equals to 5.
What's that? Yeah, when we do something like this, there's either going to be an x or it's going to ask you, hey, will this work? And then you have to go through the reasonings. Does it make sense and all that? Okay. What's up, Hannah? Yeah.
Yes.
Yes.
Should we tell you how?
Yes.
You take away the ends.
All right, so you get, well, if it was 3, what would it work? You get 5?
Wait, no, if x equals 5.
Okay, because then you did what?
And then I put it in.
Right. So you go back and double check it. What's 5 plus 4?
54.
Subtract it out. So it works itself out. It's one of those things that I think you were getting at. You know, what happens if it doesn't work? Well, sometimes you could get the value that it doesn't show. But if that occurs, especially if they're asking you to find the value of x that makes it work, if it doesn't work, that means you've done goofed somewhere. Just go back and look. All right.
Okay. Excuse me.
Same deal here if you're working with angles. If you're working with angles when you're talking about with the parallelogram, it's the same basic idea. You have to make that decision. Are you talking about opposite angles or consecutive angles?
Guys, if they share a side, they're consecutive.
It's 180.
Those are
But there
sharing a
might be
side.
the same number.
Correct, but could they be?
Oh, I see what you're saying. Yeah,
How?
opposite means like Mr. Murphy over there and over there.
Oh.
Opposite angles. If it shares a side, they're consecutive.
Wait, they're not gonna be the same number?
They're not gonna be the same number, because one of them will go in here, they'll go in.
But could they be?
Oh, if it's a rectangle, but if it's a rectangle,
Right.
yeah.
So I know. I'm just saying though.
Oh.
Could they be? That's all I'm asking.
So
What happens if they did this to you and said, what if they threw that at you? Then could they have been the same angle?
And you guys on the SAT test, right, they're gonna, you need to know that. Okay, just because a picture looks like it's 90-degree angle, if it's not marked 90, it's not.
Every picture tells a story, don't it?
It's like-
Exactly. Every picture tells a story. I mean, come on.
Yo, your
You gotta
jokes are
see it.
terrible.
Draw a picture.
I'll play it.
Okay.
I'll
Oh,
say.
and-
No, please don't. Please don't. I'm not a big fan of your music.
Yeah.
All right. So what do you do?
Equal to 180.
ladies and gentlemen, I saw this happen so many times. Was it yesterday or 2 days ago? I don't know so much with this class, but it was with one of my other classes, is that people tend to have a giant brain fart when they have multiple things to do. When you have all of this stuff on one side of an equal sign, you're just combining like terms, which means you do 12 plus 5, and then negative 10 minus 14.
X equals to
Hold
4.4.
on. You get that. What I was seeing a lot of was people were trying to add 10 to the negative 14. It's not on the other side. I don't know. People were doing that. They're making me feel sorry. Yes, ma'am. So remember, when you're combining stuff and when everything's on one side of the equation, this is a big thing that people may or may not have remembered. You're just combining like terms, okay? That they're no good fish. Two-step equation. You get 17x is 204. Yeah, the 24 over. And then you divide that out, you're going to get 1, carry this, you get 12.
Like,
And then you check it to make sure it worked. So, when you check to make sure it's worked, what's 5 times 12? 60. What's 60 minus 10?
50.
50. So this one's 50. What's 12 times 12?
144 minus
Subtract 14.
130.
And last time I checked, 50 and 130 add up to equal 180. Happy days are here again, blah, 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 blah.
Wait, Smiley Happy People.
I hate that song. That is one of the worst
Smiling
songs.
Happy People were playing.
Shiny
it in
Happy
the class.
People?
Shiny Happy People.
It is one of the worst songs. And it was on the radio on the way into that TV station. I heard it come up and I was like, ah! I almost drove off the road. I loathed that song. I think somebody told Michael Stipe that if he could make $1 million from one song, he wrote it and he sold his soul to the devil. It is the.
Stop it.
I just thought of it because
Do you like the video?
I hate it. I don't hate very many things.
We're gonna play it with the
I highly dislike it. Hey, what's this?
Oh no!
distance.
The distance formula.
This is
Hey,
I'll just
what's
go
this?
Go on YouTube and just pull it up and play it to act as torture.
The Hornets thing. Missing angle.
Nope. Slow. So, a couple of things that will also happen, which we're going to spend the next couple of minutes on, are things that you guys always tend to forget. What we have to worry about here is that you will also not always just be given something all peachy keen and happy and whatever about
Shiny.
holding hands. Oh. Anyway, so when you get back to ones like this, you're going to be given coordinates. And if you have coordinates, one of the things that happens with coordinate geometry is that you can work with slopes and you can work with distances. Guys,
And you can work with smiley happy people.
enough, okay? And let it go. So what we're going to do is give you guys a set of ordered pairs, which means that we have to be able to figure out slopes and distances between the ordered pairs. Now, we always didn't do a lot of pure distance formula a lot of times. A lot of times we shortcutted it and used just the straight old Pythagorean theorem, which is just the distance formula in a triangle, remember? But we're going to do things like this because you can show if things are congruent or parallel by using these. All right? So let's look at an ordered pair set. Let's look at a set of ordered pairs. I've got plenty of background. Help yourself. You know where it is. So when we look at a set of ordered pairs, when you have a quadrilateral and you're trying to see whether or not it is a true parallelogram, how many sets of slopes would you have to check? 4 of them. Okay. Which means you're going to look at the slope of AB, the slope of BC, the slope of CD, and move this over just a little bit, and the slope of AD, or DA. It doesn't matter which ones you're going through. Okay. You're going to check 4 separate slopes. Okay. Which means you're going to use the slope formula 4 separate times. It's just a matter of remembering what you're looking for. Okay. The slope between A and B. Well, here's my first set of X's and Y's. Here's my second set, if we forgot how to do this. One of the reasons why I want to bring back the whole idea of working with slopes and stuff is because slopes and distances and things like that is one of those all throughout high school spiraled things. You're going to see it over and over and over and over again. It's something that does not go away. Okay? Writing equations of lines, things like that. This is one of those pure high school math things that you see. So if I do this, I have the change in y, 3 minus 3, over the change in x, 4 minus negative 1.
Wouldn't it be like undefined?
Can I have 0 in the top? Because what's 0 divided by 5? 0.
Oh,
Well, what's 5 divided by 0?
undefined.
That's the undefined. Okay. So in this case here, my slope, does this become 0 over 5? So my slope here is 0. Okay. Now, also, real quick reminder, when you're dealing with slopes, if things are parallel slopes are always what? Do you remember? Yeah. Parallel slopes, parallel lines have same, oh, let me see this. Rewrite this. Parallel lines have same slope. Okay. So our first one is slope of 0. All right, go to the next one. First set of x's and y's, and so on. Negative 1 minus 3. 2 minus 4. Well, remember, you can use the fraction bar in your calculator and just type everything in exactly the way that you wrote it, and you'll get the same answer. So I have what? Negative 4 over negative 2, which is? And it's actually just 2, because negative divided by negative is positive. Okay? Remember, throw it in your calculator. Use the fraction bar, use your signs and things like that, and you're going to be okay. Oh, I forgot to put the B, or put the C in there. Thanks. Slope of BC is 2. So now we have to check to see if one of the other ones start becoming parallel. Now, what's nice about this is that if you get to the third segment, if it winds up being parallel to the other 2 at all, you probably know you're not going to have a parallelogram because you have to have both sets parallel. If you don't, just double check your math and you can say no. All right, so if I check the next one, well, let's see here, we get negative 1 minus negative 1 over negative 3 minus 2. Hey, I get a 0. Does it even matter about the denominator? Actually, it doesn't, because what's 0 divided by anything?
0.
0. So right away, I know that AB and CD are parallel to one another, so that's a good sign. Which means I just have to do one last one with A and D. Okay? Does that make sense? What we have to do? We're just going through it step by step just to check them. So let's see here. We have negative 1 minus 3. Negative 3 minus negative 1. So that's a negative 4, and that's a negative 2, and dun dun dun. Opposite sides are parallel. Do we have a parallelogram? Great. Now you can do that with slopes, or you can check that the whole time with distance formula. Which one do you think is easier? Slopes. Slopes are a little bit easier to work with when you go through those. Okay, slopes will be a little bit easier to go. Why don't you try
I got -1/5.
Yeah.
Negative 1/5. Okay.
And then that one's. That's like undefined.
You got undefined. Yeah, that makes sense. So it'd be undefined.
I was wrong.
Yeah. Anything over 0 is called. You just call it undefined. That's fine. Again, because parallel. If 2 of them are undefined, then you're okay. Then what do you get for CD? Is 1 over -5 the same thing as -1 over 5? Remember that a lot of people always question that. It means the exact same thing, guys. -1/5 is 1 over -5 is -1. The floating negative symbol is okay. It happens all the time. All right, it happens all the time. And then the last one, when you have the x values that are the same, you can see that right away. You have another undefined slope. Yep. Remember when we did write the equations of lines that are parallel, write the equations of lines that are perpendicular? If you have parallel line or undefined slopes are parallel to undefined slopes, 0 slopes are parallel to 0 slopes, 0 slopes and undefined slopes are perpendicular to one another because horizontal lines have 0 slopes, vertical lines have undefined slopes. Remember the blue line? What's that? Right. Remember how it had the blue lines in your paper with the red ledger? That's all it was. Yeah.
How is that
Undefined. Well, when you look at anything that you take any number, let's look at AD. So if I have 0 minus 3 over -2 minus -2, I get -3 divided by 0. Anytime you divide by 0, it's what you call undefined. You can't do it. How do you split something into 0 parts?
It's like nothing.
You can't because you
Can't.
can't split it.
You
can't
can't
s-
multiply 0 by any number
To
to
ch-
get -3
Right.
answer.
But you can take -3 and divide it, or sorry, if you take 0, if you start with nothing and try to divide it by a number of things, you still have nothing. But you can't take things and divide it by nothing. That's why it's undefined.
Or like we have the 0 over 5. I always think of the opposite operation of fractions, which is multiplication, because fractions are division, and you say, well, I can multiply 5 by 0 to get 0. That makes sense to me. So that's a 0 slope, but I can't multiply 0 by something to get
If I take my piece of pie and I want to cut the pie,
A sector?
yeah,
I think your pie is
A sector?
squint, you'll be fine.
that's 7 pieces.
It don't even work.
Does it matter if I do 7? You know what? My son loves to have 5 slices in his sandwiches. You know, when you cut things in triangles, you to triangles or squares. They say, yeah, I would like 5 triangles. So we cut 5 triangles out of the
My son
square.
always asks for 2 halves.
Okay, here you go.
You want a whole sandwich?
So
No.
what you can do here, can you take this and can I cut this in half? Yeah, I can cut it in half. I divide it by 2, and then I just cut it in 2. But if I take it, can I divide that by nothing? How do you do that?
Magic. You just don't
Right, but you can't do it. You can't divide it by nothing. You can cut it into one piece.
How do you
Here's a
divide
piece.
that square into 5?
I do it 5s. You take a square. He wants triangles. I'll go like this, and then I'll go like this.
That's 4. Ooh.
Oh.
That's how he gets 5 square or 5 triangles.
He gets 2 right angles. 2.
It's fractions at an early age. He just doesn't know it. So do these, please.
Oh my. That is not that much.
You'll probably use the slope stuff more than you will use distance formula. Actually, you will use slope more than you will use distance formula on these things. Those first grouping, those first 8 through 14 is quite literally, are they opposite angles congruent? Are they opposite sides congruent? Are they diagonals bisecting one another? It's just solve for x type ones. from there, okay? Excuse me. Then I think the 19 through 21 are the slopes. You'll just find the slopes. What's that? 25, 26 is a little bit trickier one. I want to see if you can figure them out. I want you to see if you can do it. I'm not going to tell you how to do it. I want to see if you guys can try it. They're not. You're finding a missing endpoint that makes a parallelogram.
Okay.
I want you to see if you can figure that out. Do not put up shiny happy people.
What?
Actually, oh, you are. No, no! I gotta stop the recording anyway before the internet police will cut me out.
Oh, it's not approved. Can't we just play the song?
Well, no, I can't record it because if I.